Hey everyone, Mr. Newman here, and we're going to go over some free response questions in the position, velocity, and acceleration. And so I just want to walk through some of these with you. What you might want to do is you might want to try some of these questions on your own, see how far you get, and then watch the video because these are problems that you guys could probably do. The thing I do want to point out though is you notice how complicated these are, like 2 sine e to the t over 4. These are calculator active. Notice this is a calculator here. Calculator for response, but it's meant for you to test out and see how well you can use the calculator and solve this, not how well you can do it by hand, right? So we are going to have that be a part of it, okay? So let's go ahead and read this and get started. So for 0 to 6, a particle, let's mark that in red, 0 to 6, a particle is moving along the x-axis. The particle's position is not given. The velocity of the particle, though, is given here. And the acceleration is given here. So they took the derivative for us. So we know that's the derivative and that's velocity. So the question is the speed of the particle increasing or decreasing at time equals 55? Make sure your calculator is in radian mode. So just as a reminder, remember it's under mode here. I don't know which one, what yours looks like, but as long as you go down, I think it's the 4th line, you want to make sure you're in radian mode, not degree mode. So we're there. So I will quickly type this in. We have 2 sine, I say quickly, e to the t over 4. In this case it would be x over 4. And remember, for some fractions, alpha y equals, if you want it to look just like what's on there. Let's go ahead and also type in acceleration, just for good measure. So I have alpha y equals 1/2. Show you at the end when I've got it all typed in here. I use second natural log to get e to the x. It's just a little bit faster. X over 4 of course instead of t over 4. Then we have cosine of e to the t over 4 again. In this case, x over 4. Alright, I'm checking to make sure I have these typed in correctly. So the first one gives the speed of the particle increasing. Is it increasing or decreasing at time t equals 5.5. Well, the speed, remember, speed is increasing if velocity and acceleration have the same sign. So I'm going to come over here to my table. I've got them both plugged in here. And I'm going to make sure my table setup is on ask. It is. See, the independent is on ask. So now I go over the table. And I don't need all these other entries. Let's delete them except for I'm going to type in 5.5, enter. Okay, in this case, I see that, remember my first thing I entered was the velocity, and the second was the acceleration. So I see that my velocity and acceleration are both negative. And so I can say that it is increasing. Remember, I'm saying speed. The velocity is actually decreasing because acceleration is negative, but speed doesn't care whether we are, which direction we're moving in. As long as the acceleration and velocity are in the same direction, the speed is increasing. If velocity and acceleration are in opposite directions, if one is positive and the other one is negative, then the speed is decreasing. So increasing because v of t, actually I could say v of 5.5 is less than 0, and a of 5.5 is less than 0. So, great. For 0 to 6, the particle changes direction exactly once. Find that time. So for this one, I'm going to graph it. So let's go to, actually, let's go first set up in the window. Okay, so I'm going to click on the window. I'm going to make sure it goes from 0 to 6 on the x. So 0 is my x min, 6 is my x max. Let's go to zoom fit. So zoom 0, zoom fit. Just go down and find it. I'm trying to make the window fit the graph. And so I went and pressed it. It's coming slowly here. So where does the particle change direction? Well, it's when our velocity goes from being positive to negative or negative to positive. Because remember, the sign of the velocity is the direction it's traveling. So notice here, the blue is our velocity. It is traveling in the positive direction most of the time. Then just a little bit past 5, it changes direction and starts going negative. Now remember, it doesn't look that way. We don't have the position graph, so it doesn't look like the line is changing. We have to remember it's in the abstract. It's when the velocity is positive, it's going one direction. When it's negative, it's going the other direction. So we're trying to find this point of intersection right here. Let's calculate that. So a few things. You could, some people like setting y3 equal to 0, just finding the intersection. Left bound, we're left there. Right bound, I'm going to press 6 instead of waiting to hold down the line. And I'm going to make a guess. Honestly, most of the time you just click enter right away because the calculator is way faster than us at finding these. 5.195 or 6. So 5.195 or 6. Now real quick, let me back up. We need to do a little bit of work, find that time. When does the particle change? We want to say when v of t changes sign. Changes sign. And right here is where it changes sign from positive. In this case, it's changes sign from positive to negative. Okay, so find that time. There we go. That is in, does it say? It doesn't say seconds. Yeah, it doesn't give us any units. Okay, we'll leave it at that then. Okay? Alright, moving along. So one other thing I want to point out. These are former AP Calculus questions that are released that we can share with you guys. I will say that this is not all of the parts. We only have, I think, 4 parts on this question and maybe 2 of 3 or 4 or 5 parts on the second question. So the other parts, of course, we haven't learned yet. But these are parts of questions that you guys will likely see, things like this, on the AP test. Okay? So moving on to the other AP test question, the free response. For t greater than or equal to 0, a particle is moving along the x-axis. The velocity is given by time t here. So let's come back here and let's go ahead and type this in. I can't make that any smaller. It's really annoying. Okay, I will go and type it into y equals. So I'm going to clear out what I had there. Let's get 1 plus 2. Oh, that's a typo. It's supposed to say sine of t squared over 2. Now I'm going to just be careful and, oopsie, I just deleted a bunch of stuff. Okay, try this again. 2 sine of t squared. Oh, I know that's what I want to do. Alpha y equals t squared over 2. So see, I typed in y equals, so it looks like that. And it's t squared, in other words, x squared over 2. Remember, I knew where there's a t. Our calculators only like to see x in there in the current mode. Yeah, we'll scribble one of these out. This is supposed to be sine of t squared over 2. All right, at time t equals 4, is the particle speeding up or is it slowing down? Well, refresh here, I think I'll do this. Let's see if I can fix it. Oh, it's going to take a second. Is it speeding up or slowing down? Well, for this, let's go over to the table. We can simply look if it's positive or negative. I'll type in 4 and see what we get. That is positive, so that means it is going in the positive direction, but that doesn't tell us if it's speeding up or slowing down. Ah, here we go. I fixed that, but we have other problems. There we go. Okay. So I'm going to show you guys the trick. We could take the derivative of that, but the other thing we could do, since this is calculator active, we could have the calculator take the derivative for us. So here's what we're going to do. In fact, I'll go ahead and do this. I'll show you another way to do this. So if we go to math and inderiv, see that's number 8 right there, inderiv, I want to say d dx, the derivative with respect to x. I'm going to type in my equation again here, right? So we have 1 plus 2 sine of x squared over 2. Okay. So let's see, I typed it in a little faster that time. Second time, get a little better the more you type in the calculator. At time t equals 4. So here I want to plug in, instead of just leaving that blank, I want to plug that in. I want to say, what about when x is 4? And this is actually in the calculator, the derivative of this function with respect to x at x equals 4. Okay, so press enter and it calculates it for me. Ah, that is negative. And so I can put here that, we can even call it a of 4, acceleration at 4, is equal to negative 1.164. Negative 1.164. So, let's see here. We had our table. V of 4 is positive, 2.978. 8, or rounding up to 9. And so if we have a positive velocity but a negative acceleration, the signs are opposite. So the particle is slowing down. Okay, so remember words like speeding up or slowing down is just cares whether the acceleration and velocity are the same sign or opposite signs. So the particle is slowing down because A of t and V of t have opposite signs. Right. One thing I realized, how I put these two together here like this so that I could write these down here, A and B, and we could organize our work. And I'm writing all the work up here. I apologize for that. But yeah, that is one thing on the AP test. They give you all the problems all together, and you have a bunch of space to fill out your work. So you need to make sure you're organized with your work. So actually, let's see if I can do that real quick. You guys are not going to have to change anything. There we go. Oh, I had that little thing there. Okay, great. So that's part A. Let's look at part B here. Notice, yeah, you do want to practice organizing your work like that. Find all times t in interval 0 to 3 when the particle changes direction. So we have our graph here. That is the velocity. So the changing direction would be when it crosses the x-axis. It says from 0 to 3, so let's change our window. Go instead of 0 to 6, we want to go 0 to 3. And we'll go back to zoom fit, zoom 0. So remember, changing direction is not just when it hits the x-axis, it needs to cross over the x-axis, go from being positive to being negative, or being negative to being positive. It looks like it only changes one time. So let's find that time. Second, calculate 0. I'm going to type in 2 is left bound, 2 is left of it, 3 is to the right of it. And then press enter to make a guess. Here we go. We have 2.707. So t equals 2.707 is the only time the particle changes direction. Because, what? Because it's the only time that the V of t changes sign. Oops, sign. There we go. And in this time, it goes from positive to being negative. All right. Okay, those are the two problems I wanted to do for you guys. We'll see. I might make another video with some hints on these, but go ahead and try these. A lot of these are very similar problems, right? Is the speed increasing? Find the time so the particle changes direction, and find the values on the interval for which the speed of the particle is 2. Of course, the speed of the particle to being 2, one thing I want to remind you of, speed is absolute value of x. So here's where, we have this. You can graph it. You can type in y equals 2, but you also want to check y equals negative 2. Another trick is when you're typing it in, if you put that in absolute value bars, but to me it's more intuitive to think, just ask, when is, okay, so this is y1, right? You plug this into y2, and you plug this into y3, and you just check and see are there any times where the velocity is positive 2 or negative 2? All right. But yeah, so that gets you started. And of course, these are slightly different. You'll want to go through and check those, but you can compare those to the other notes we had before. All right. Thank you guys very much for watching.